You have been lied to.
My fellow Americans,
Why lying with statistics is so easy.
tonight I want to speak with you about our nation's coronavirus outbreak
A COVID case study.
that started in China and is now spreading throughout the world.
Coronavirus!
Experts say that around 1 in 3 patients admitted hospital in the UK with COVID-19 have died.
There are more than 1.6 million confirmed cases of COVID-19.
Billions of people made life-changing decisions based on COVID statistics. Most statistics were technically correct, and still the picture the media painted was fundamentally distorted. 5 tricks, all documented, all used throughout the pandemic to a very big extent.
100,000 Americans, 2 have lost their lives.
And at the end, there is one question that cuts through all of them. When COVID was at its peak, everyone were looking for vaccination, and then it came.
The drug maker says its COVID-19 vaccine is 95% effective.
95% effective. True, but here's what it actually means. Unvaccinated people, 0.75% got COVID. Vaccinated people, 0.04%. So a relative reduction of 95%. 0.75 to 0.04. But if you look at the absolute numbers, the absolute reduction, the actual change is just 0.71% percentage points. Same trial, same data. 2 completely different stories. Neither number is wrong, but only the 95% got the report.
It's 95% effective.
95%
is 95% effective.
So this is the rule here. The relative numbers are always bigger. Bigger sounds more convincing. So you lead with relative and leave out the absolute numbers. But what if I don't need to hide a number at all? What if you just need to choose which dataset you show? So this leads us to the second trick, the cherry picking. So let's go back a little bit further in time. In the early pandemic, there were 3 countries, 3 mortality rates. Italy, 10%. Germany, 2%. South Korea, just 1%. But how can it be that Italy had so much bigger death count than the other 2 countries? So this is where the cherry picking comes into account. Italy tested only hospitalized patients. On the other hand, South Korea, and for a large extent Germany too, ran mass community testing. So they also caught mild symptoms and asymptomatic cases too. So they had a much bigger dataset. Same virus, different sample, different results. Both sides cited real data. Neither mentioned what was really being counted. So here's the rule. You do not need fake data to lie with statistics. Just pick the dataset that fits your narrative.
Many countries are still facing surges in deaths and cases.
The virus is very, very deadly.
3 million people have died from COVID-19.
And presented as the whole picture. The death count in Italy is so high, we need the lockdown immediately. That was the narrative this data fit perfectly to. But what if I told you there's a trick where you do not even need cherry-picked dataset? What if I told you that it's just enough to show the real data on the wrong level of detail? So this leads us to the third trick, the missing stratification. By spring 2020, the COVID fatality rate for children was 0.0002%. For people over 85, more than 15%. This is a 10,000-fold difference. To get this into perspective, this is the change of chance if you just throw 1 6 at a dice or 5 6s in a row. That's the difference. Can you remember which of these 2 numbers were in the public discourse?
Next, the ongoing coronavirus threat, the death toll in the U.S. now officially topping 110,000 and closing in on 2 million confirmed cases.
The number in the public discourse was neither 0.0002% for children or the 15% of the elderly.
110,000.
It was an average mortality rate. So a 7-year-old and an 87-year-old, they were treated statistically equivalent. So this is what happened. So if you do not differentiate between those 2 groups, you will implement policies which will affect everyone the same. So you apply the same rule for groups where the risk differed by 10,000 times. This is the rule here. Averages hide distributions. You cannot differentiate anymore between one group or another. And hidden distributions hide the truth as well. But What if I told you that you can cheat with statistics without even hiding any distribution? What if the right data with the wrong question flips the conclusion entirely? So we have 2 tricks left. Trick 4 is the most dangerous one. So same data, wrong question, opposite conclusion. Stick around to the end. I will reveal the one question that will cut all of these 5 tricks. We are a little bit further into the pandemic. The year is 2021. The vaccines are distributed violently all over the world.
Of just over 1 million vaccinations a day.
At the same time, the vaccinated population made up a growing share of COVID hospitalizations. Real data.
As the race to vaccinate across the country ramps up, hospital admissions climbing in 20 states, the U.S. now averaging about 5,000 new COVID hospitalizations per day.
But this was immediately used as proof that the vaccines do not work.
The COVID vaccine is not reducing hospitalization. It's not statistically significant.
But there's one problem with this assumption. If you vaccinate the high-risk people, the elderly, more than the rest of the population, then of course they will dominate in the hospitalization, not a vaccine failure. So the right question in this scenario is not what share of hospitalizations are vaccinated. The right question would be, what is the hospitalization rate in each group for each subsample?
Does the COVID vaccine reduce the rate of death for children under 18?
If you looked at this data, this showed that vaccinated people were far less likely to end up in the hospital. Same data, wrong question, opposite conclusion. This is the rule here. Correlations find a pattern, but causality explains it.
Let's look at this graph, and we observe this strong relationship.
Mixing them up could reverse your conclusion entirely.
We're not assuming that wearing shorts causes you to buy ice cream, or that buying ice cream makes people wear shorts.
But what if I told you that the distortion doesn't even need to happen in the analysis? What if the distortion already happens before even a single data point is even collected? Let's look back at the Pfizer trial.
The massive operation to deliver potentially life-saving vaccines across the country is ramping up.
The Pfizer trial had 40,000 participants. That's a massive study. But the study had a sample of predominantly healthy adults. The elderly, the highest risk group, were underrepresented massively relative to the share of the actual death count. But overall, it's a clean sample. The problem here is when the vaccine reached the 80-year-olds, which already have been barely present in the original sample, the real-world results looked very different to the trials Pfizer did.
Many countries are still facing surges in deaths and cases.
Not because the trials lied, but because the sample wasn't built on how good does the vaccine work for the most risk-exposed group. If the sample does not match the population, the finding is real and irrelevant. So as we all lived through the pandemic, which of these 5 tricks did you fall for? We've seen 5 tricks. 0 fake data. Just 5 ways on controlling what you are comparing the numbers to. And here's the question which will reveal everything of that. Compared to what? Compared to what is the number large? Compared to what is the risk high? Compared to what is this a good average or bad average? Compared to what is the population representative? 2 words, works every time. The most statistical manipulation isn't complicated. It's just a number presented alone to an audience that never learned to ask what it should compare to.